First of all, read the question. A block placed on a horizontal surface experience force as the given, then find the force applied by the surface on the block and angle of the friction. So first of all, our motto, we have focused on force applied by the surface on the block. Okay, block always apply two forces in the surface, apply two forces on the block. Which one? First of all, make that free body diagram of that block. That is 2G. We have taken G this equal to for simplicity point of view. Otherwise, you can choose 9.8 meter per second. We have choose only 10 meter per second. So 2 into G, that is 20 Newton. 20 Newton. And here applied force 50 Newton. Clear? Now force applied by surface on the block. There are two forces apply. Surface apply two forces on the block. First one, normal force. It is perpendicular to the surface. That is N1. Always perpendicular to the plane, like that one. And second one is a frictional force. It is parallel to the surface. And what about direction of that force? It is opposite to the applied force. It is opposed the motion. That's why this direction is like that one. Clear or not? So what about N1? In balance condition, N1 is equal to 20 Newton, normal force. Clear? Now here mu s and mu k is given 0.9. So first of all, determine frictional force, limiting frictional Fs max. This is equal to mu s into N1. 0.9 into N1 is 20. That is 18 Newton. And kinetic friction, that is mu k into N1, that is 0.9 into 20. This is also 18 Newton. Clear or not? Very simple. After that, first of all, make it like that one. Next one, if this block is moved, suppose that is this force is capital F. If suppose that block is moved, only possible if then net force is capital F minus small f. So if you written as A, so F minus small f divided by mass m. If this block is moved, only when if capital F is greater than small f, FL, limiting friction, applied force is greater than limiting friction, then this block is moving. This block is moving. Clear or not? Applied force is 15 Newton. And what about frictional force? That is 18 Newton. Applied force is less than 18 Newton or greater than. This force is greater than this one? No. Frictional force is greater than applied force, means FL is greater than capital F. It is more, this is equal to 0, but here A is 0. If first case, here second case. Limiting frictional force is greater than F, then what about oscillation of that block is 0. Block always in rest, that time rest. Okay. So you can say that if A is 0, then F minus small f divided by mass. If this one is 0, means F this is equal to small f. It means what about F? Capital, this is equal to capital F. Capital F is 50 Newton. So it is written as 50 Newton. That is 50 Newton. Okay, clear or not? That is 50 Newton, and this force that is called static frictional force, that is 50 Newton. Clear or not? Very simple. So frictional force Fs is written as, that is 50 Newton. But our motto, we have focused on force applied by the surface. Force applied by the surface. Here two forces, normal force applied by the surface on the block. There are two forces. First one, this one, and second one like this one. Okay, clear or not? So means resultant of these two. We focus on resultant of these two. Okay, not asking normal force, not asking frictional force. If asking normal force, then N1. Or asking frictional force, that is Fs. But he asking force applied by the surface on the block. So resultant of these two. We focus on resultant of these two. Clear or not? So we draw here N1 and frictional force direction like that one, that is Fs, and that direction, that is R, resultant force. So what about R? Simply under root of Fs square plus N1 square. Put this value. Fs is 15 and that is 20. 15 square plus 20 square. This is equal to how much? 20 plus 15. How much? That is 25 Newton. So this one is 25 Newton. Our next target is angle of friction. Angle of friction is resultant of the force applied by the surface on the block and normal force. Angle between these two, that is lambda. So tan lambda is written as Fs divided by N1. Fs is 15 and N1 is 20. So 3 by 4. So lambda this is equal to tan this is equal to 3 by 4. Lambda this is equal to tan inverse 3 by 4. Clear or not? If anyone say, please define, sir, angle of friction. So first of all make it, after that we have defined. Take make it, first of all make it. Angle of friction, angle of friction, heading. How can define? Angle made by resultant force applied by surface, with normal force. That one is normal force. That is called angle of friction. Angle of friction. Clear or not? Make it. Angle of friction. Angle made by resultant force. That is resultant force of applied by surface. Applied by surface. That's why it is known applied by surface with normal force. N1. That angle. Clear or not? Is called angle of friction. Clear or not? Simple. Make it.